Subscribe to AmpCode and ring the notification bell to get the latest content.
Hello and welcome back to the channel. In the previous lectures we have seen all about the data lakes and how it works under the hood. So basically all we are going to do is get our hands dirty and work with one of the data lake. And what will be the best than Hadoop, right? Because Hadoop we already know that it's an open source framework which is distributed for storage and processing the data, and we can say it as big data. So we already know what really is a Hadoop, and it's a great choice for data lake applications. So it provides you the HDFS, which is a distributed storage system which will ensure you the high availability as well as the data replication, and you can set up the replication factor as well as per the criticality of the application. Then you got a Yarn, which is a resource manager which schedules a job across the cluster, and also we got MapReduce, which does nothing but parallel data processing across the distributed cluster. Then for analytics and data processing we got a Hive and Pick, which gives us like SQL like querying on top of your data, and the data could be a structured way. And then we got a HBase and Spark, which will give you the NoSQL capability, which stores the data in a loosely structured or semi-structured format, and also the most favorite tool for everyone in the data community, which is Spark, which will give you the in-memory data processing. So due to this Spark is a great data lake choice for every data organization. So to jump into this, you just have to kick off your HDB sandbox, which is give you the capability to trigger your Hadoop cluster on your local machine. We already set it up, so what are you waiting for? Just kick off your HDB sandbox and launch the Ambari and wait for all the services to get started. Okay, so as you can see, I have already kept my HDB sandbox running, and as you can see, most of the services are running fine without any issues. There are a few warnings in Hive, but we can ignore that now. Basically all our services are running fine, and all you have to do, and this is our data lake. So in data lake we can store huge amount of data, which is maybe a structured one or the semi-structured one or maybe unstructured one as well. So if you go into the files view, all you can see is the HDFS. So this files view will give you the capability to upload any files in the HDFS. So there is no such structure to that file which is required. So as you can see, we got the directory based, and we can access that using the terminal as well. So basically we have already set up PuTTY, which is a terminal which will give you to communicate with the remote server. So in this case we have our Hadoop cluster, so it will directly communicate it and using a simple HDFS command, which is like put copy from local, copy to local. So we have already seen this command in the previous lectures as well, for putting the data, for navigating and also putting the data or downloading it to the local system from HDFS. So as you can see, we can create a new folder, we can upload a file from our local disk. This is how we can do it. So basically to work with the data lake, let's have some application. So basically we can build a Hive table on top of the data, which is already present either in the HDFS or on our local system. So local system is nothing but the Unix box where you have installed your Hadoop. It's not on the Windows, it's on the Unix box. So basically we have the virtual box environment on which we have deployed our Hadoop cluster, as we already know and discussed in our previous lectures. So basically all you can do is to access the Hive view, you can just go into the Hive view right now. So it will check all the services which are in running state or not. So this is checking for HDFS, the Hive server, ATS, as well as the user home directory test. So once this is done, then we can directly query our database without any issues. And HiveQL is nothing but similar to SQL queries itself, just there are some syntactical differences and the available functions than SQL. So for this tutorial, let's have one script which we want to run to able to upload the data into HDFS, or else we can create directly upload the data into HDFS and create a Hive table on top of it, and we can do all sorts of analytics in the data lake itself, which is Hadoop. So basically all we can do is we can create a new database known as movies, and then we will create a ratings table here. So we are going to create a rating tables on top of a file which is present in HDFS. So basically our table will be having like the user ID, movie ID, rating and the timestamp field, with their respective data types, and then after that we have to provide the schema for it. So basically this is nothing but the table which is like row format delimited, and the file will be the tab delimited. So our data file is nothing but the ratings.data, which will be present in the HDFS, and the line, and this is nothing but the tab limited file. So I hope you already know about how the tab limited file looks like. If not, let's talk about that as well. So basically all you can do is, the command here is you can load the data from local data file, or else you can load it through the HDFS as well. So after that, once the table is created on top of it, then it will be good to go to do our data analytics. So here we can get the metadata of the table using the describe command, then we can get the counts and also get the number of occurrences of each rating in our table. So this will be pretty simple to implement. So the one prerequisite will be your HDP sandbox would be up and running, and also the Hive services are running fine without any issues. So without wasting any time, let's jump onto it and execute this on our HDP sandbox. Okay, so the next step would be like you have to connect to HDP sandbox using the SSH. So for that purpose we are going to use Putty terminal. You can also use like other tools as well if you have like the mobile term, but we have already set up Putty in our Hadoop tutorial, so we are going to use that. And then just you have to give the Hive command. So you just have to go Hive and enter, which will open your Hive shell, and here we can able to run and execute the whole thing here. So here we can execute directly the SQL statement. So let's say if you want to show like the databases, that we can also do. So once it is submitted, it is converted into like the map reduce job, and here we go, we got default, food mart and the movies data databases. So here all we can do is, we have already seen what are the different steps that you need to take to able to load the data from the data lake, which is nothing but the HDFS layer or the Hadoop we can say, and we can load that data into Hive, which is used further for the analytics. So here it's a simple example of a data lake on that we can set on premise. So we can just drop database if exist command. So as you already know, the movies is not present, it's a movies data. So that's it, the command got executed. After that we can create a table, we can create a database which is movies. So this nothing but creates a database. So it will take maybe 1 or 2 seconds, and there you go. So once you submit the show databases, now you can able to see the movies. Now we can able to create the ratings data table. So as you already know that we already have a file which is present locally. If not, you can download it through Git. We already have that file present in our GitHub repository. Let me show you that data. So as you can see, this is our file which has like several columns, and it is related to the movies rating. So here we have the column as the user ID, the movie ID, as well as the rating that particular user has given to some movie, and then we have the timestamp. So basically according to that, this is our schema. So here we have already talked about it, so we'll just going to execute it. So once it is executed, it will create a table in our movies data database. So here the command has failed because we already have the ratings table, but we have done one mistake that we haven't used our movies data, our movies database. So we'll just give the command as use movies database, use movies here. So once we use movies, then we can able to execute the same command without any issues. So as you can see, our table has been created. So we can give the command as show tables. So as you can see, we got the ratings table already created, and we can maybe load the data which is already present in our data lake, which is nothing but the ratings.data. So we're going to use load data local in path, and here the data could be also present in some other sources that also you can integrate with Hadoop. So as you can see, loading the data into table, and there you go, it loaded the data within few seconds. So this is the power of Hadoop, but you will able to understand that when you will go and learn up and work work with the big data, because it will kick off the MapReduce job or the test job according to the engine that we are using for execution of the Hive queries, and then it got distributed across the cluster and able to process the big data. Since it's a small file, we are not feeling that kick in our job. So here we'll just describe it. So basically describe will give you the metadata of the table. So here we got a user ID which is integer, the movie ID, rating, as well as the timestamp, which is all are present in the integer, and we have set the schema in our create table statement itself. And if you want to get the counts from our ratings table, that we can also do. So as you can see, the job is launched. So it will maybe take some time because it's aggregated function. So as you can see, this is like the initiated. It has created one map function and the two reducer functions. So this info, this is the groundwork which it is doing under the hood. So as you can see, it was not that much small files. It already has the 100k records in that, and we just inserted those in a matter of seconds. But our big data application can go over billions of records. So to able to do that, the distributed computing will kick in, and that file will be stored across the cluster according to the partition size that you have set while configuring your cluster. So as you can see here, you will able to find that how the job works under the hood. It will give you like the what are the different map functions, the reducer function. So as you can see, these are the vertices, the status. So earlier it was initiated, then it got succeeded, and here the completed, running, as well as if some process fails, you will able to understand in which stage it got failed. So this is the power of the distributed computing in Hadoop. So as you can see, we also have some analytical query to get the number of occurrences for each rating. So here we are just selecting the rating and getting the count of rating from the total occurrences. So here this is a simple analytics that you can do on top of your data. So I'll just execute that query and let's see what are the results. So here again, it has created one map function as well as two reducer stages, which contains 2 tasks and 3 tasks simultaneously, and one is running now, and there you go. So you got like the 4 rating is pretty popular, and no surprise, we all know that many of the people will not give you the extreme 5 but the 4 rating all the time. And I'm surprised to see that 1 rating has given very less often. So everyone watched and liked their movies. So which means that most of the peoples really like the movie they watch in this dataset, and this is a real dataset. It's not a fake data. It is distributed by IMDb. So it's the IMDb data, but I'm not sure which year this data belongs to, but because it's only 100k records, so only 100k users information it has. But you will able to understand how we can set up a data lake. So you already have a SDP sandbox. So it's kind of a data lake. You can able to work with variety of data, integrate variety of services. So here we have integrated Hive and also used HiveQL to able to execute the queries. But you can load the data by various things. So you can, if your data resides in like a MongoDB or the Cassandra database, you can easily integrate that using the appropriate connector that particular service will provide. So I hope you understood how to integrate all the services and set up your small data lake in this lecture. So I'll see you in the next one.
So that's it for today. I'll see you in the next lecture.